All right, ji, assalamu alaikum and welcome back again. Yes, I'm here.
Alaikum salam wa rahmatullah.
Yes. Thank you. Thank you.
Mr. Kashif, can you give us the number of the practices that we did already from the lab?
Yes, until now we have completed one lab exercise only. That is lab 1-2, VLAN configurations. This
Yeah,
one.
I mean for the past 2 days also.
Yes, for the past 2 days we have completed. I think it is in the other one. Okay. For the past 2 days, we have completed the basic configurations and IP routing. So that's comes here.
Can you give us the number from each file? Like
Yes. I'm giving you. We have completed module 1, module 2, and module 4. Module 1, module 2, and module 4.
From the entry lab guide.
Yes, from the entry lab guide.
Okay.
Yes.
From the intermediate only 1-2.
Yes.
Okay, thank you.
Okay, after that, we are supposed to move on with the STP or the spanning tree protocol. I believe many of you are very familiar with the spanning tree, and now we are going to start with the same. Okay, let us say STP or the spanning tree provides redundant, loop-free layer 2 network. So let me type it here for you. The next protocol, the next topic is going to be the STP. The spanning tree protocol, it provides...
It is a LAN protocol or...
Yes, it is a LAN protocol. Redundant, loop-free, layer 2 network. Right? Now, what is the problem we are going to address with the help of spanning tree? So let us take an example of a topology, a lab exercise. We have switch 1 that is connected with switch 2. So switch 1 is connected with switch 2, and on every switch there are few users connected. Like on switch 1 there is PC1, and on switch 2 there are PC2. It is connected on port number 1, it is also connected on port number 1. This is port number 2, this is port number 3, this is port number 2, and this is port number 3. Okay, in this picture we may have possibly number of problems, right? Whenever we will use redundant links. Here you can see between switch 1 and switch 2 we have connected two links on port number 2 and port number 3. Likewise, on the other side we have connected two links. So whenever there will be multiple links between the switches, we may face certain problems, right? So what could be those problems? It says whenever we talk about the switches, we know the by default MAC address table is empty on both of the switches. So these are the MAC address tables of switch 1 and switch 2, and they are empty MAC address tables. So let's assume switch 1 is going to communicate with the switch 2. Whenever PC1 will try to communicate with the switch PC2, the traffic will enter from the PC1 to the switch 1. And switch 1 will record that port number 1 is connected with the PC1. Now the traffic will be broadcast or unicast. Please respond very quickly. PC1 is going to communicate with the PC2 for the first time, so it will unicast or broadcast?
Broadcast.
Broadcast. So the broadcast will be forwarded from the port number 2 and port number 3 to the switch 2. Right? When the broadcast from port 2 is entered into the switch 2 from port number 2, it will record that port number 2 is connected with the PC1, and this broadcast will be sent out again. So it will forward broadcast to the PC2 as well as to the port number 3. It will enter to the switch 1, and switch 1 will write port number 3 is connected with the PC1, and it will broadcast again. And it will start doing this circle. Likewise, the other broadcast that is received on port number 3, it will record that port 3 is connected with the PC1, and it will broadcast back to the switched 1. It will record that port 2 is connected with the PC1. Or it will start creating this circle again and again. Now here you can see there are 3 problems in front of you on the screen. One is MAC table inconsistent. The MAC address table is not accurate because one system could not be connected with 3 different ports. So that is a problem. That is a corrupted MAC address table. Right? Secondly, you can see switching loops. And number 3 is the broadcast storm. There is a lots of broadcast because this is an electrical signal, so it will travel at the speed of light. So within few seconds, your network will be hang. It will stuck out, right? And all these problems are occurred due to redundant links between the switches. If we remove the redundant links, there will be no switching loops. There will be no broadcast storm. There will be no inconsistency for the MAC address table. Right? Now, to overcome all these 3 problems, we are going to discuss the spanning tree. We can avoid the spanning tree by doing one simple thing. It says, if you keep one link between the switches and at some point this interface goes down, would you be able to communicate with the PC1 and PC2 now?
No.
No, we will not be able to communicate between them. So we want to keep the interface connected, right? Now, if this interface goes down, we have to physically go to the office, physically go to the switch, and we have to attach the other interface manually. Now, if this is going to be happen at 02 a.m. in the midnight. Is it practically possible to connect a physical link in the midnight over there in the office? No, practically it is not possible. Right? Okay, someone suggested me that don't go to the office at the midnight, connect two links and keep one of the interfaces shut down. Now this is shut down with your command. Now again, in the midnight, this interface goes down at 02 a.m. Is it easy to wake up in the midnight just to undo shutdown, just to no shut down this interface? Is it possible for you?
Very difficult.
Actually, this will be, I normally call it, this will be headache in the knees. You will not be able to sleep well. You will not be able to do anything all the time. You will have one tension in your mind, that is the interfaces redundancy. Right? You have headache, but you will be taking care of the knees. Right? All the time you will be taking care the office network. So this is not the practical thing. We want to have some automation. We want to hire some service, some protocol who will keep this interface shut down. Now, whenever this interface will go down, now let's assume this is down, the other interface will undo shutdown, will get no shutdown automatically. Right? Now, this is not your responsibility to disable or enable the interfaces manually. You are going to hire a service, a software, a protocol, which will be working on your behalf to enable and disable the interfaces. Now, that service, that software, that protocol is named as the STP. STP is going to take care of the redundant interfaces. It will keep your network up and running without disturbing anything. You will sleep well, you will do your routine activities, your home activities, your personal activities very calmly, and the network will be took care by the STP. Right? Now, how the STP works and how the STP will take care of the network redundant interfaces. Now, let me show you. It says you need to support me with 3 terms. I have 3 points. If you help me in those 3 points, I will work on your behalf. It says, first of all, there should be one root bridge per network. Yani in every network, you will help me to select one root bridge. Bridge means this is a switch. So there will be one root switch in every network. Secondly, there will be one designated port in every segment. Segment means link. On every link, we have 2 ports, one here, one here. Out of these 2 ports, one port will be selected as the designated port. And number 3, and the last thing, one root port per non-root bridge. On every non-root bridge or switch, you will help me to select one root port. Now, there are 3 new things here. What is the root bridge? What is the designated? What is the root port? So first we will understand these 3 terms. Once we are done with that, we will be able to understand the spanning tree, right? So let me explain the first thing. First of all, it is a root bridge. The root bridge is a switch having least bridge ID or the switch ID. Any switch whose switch ID or bridge ID is smaller in the number will get elected as the root bridge. Now we have a new term here as well, that is the bridge ID. Bridge ID is composed of switch priority and MAC address, which means every switch in all the vendors will have two things. One will be the priority, which is 32,768 by default on all the vendors. This number is same. The STP is same for all the vendors. Then it will be a MAC address. For example, the MAC address of this switch is 00 11 22 33 44 55. So if this is the MAC address of this switch, then no other switch in this world will have the same MAC address. It will be a unique address. Now, if we combine both of them and we envelop them in a packet, this will be the bridge ID. Right? Now, this is the first thing. After this, we have the designated port. This is a port which sends best BPDU. This is a port which exchanges and sends best BPDU. What is BPDU? This is bridge or switch protocol data unit. Yani this is a kind of hello message of the switching protocol of the spanning tree, right? Okay, after this, lastly, we have the root port. This is a port which receives best BPD. Okay, keeping in mind all these three things, this is switch 1 and this is switch 2. Both the switches are connected with redundant links, like switch 1 is connected with switch 2 using 2 ports. Now the priority is 32,768 on both switches. It is by default same for every switch. The MAC address is 01 02 03 04 05. It is 00 11 22 33 44 55. Okay, both of the switches will exchange their BPDUs. It will send the BPDU here and switch 2 will send the hello message or BPDU to the switch 2. Yani they will exchange their priority and MAC address with each other. Now, whoever will have the smaller number will be the winner one. Now, priority is same on both of the switches, so no one will be able to win the election based on the priority number. Now they will look into the MAC address. It is 01, it is 00, it is 02, and it is 11. 0102 is smaller in number than 0001, right? So based on this election, switch 1 will be able to win the election and it will be declared as the root switch. And if this is the root bridge, this will become non-root bridge. Agreed? You are getting this thing?
Yeah.
Okay. After this, we are done with one thing. Now, once this is the root bridge, you can say this is the king. This is the PM now. This is elected switch. This is not elected. Now, if someone is elected, then he or she will have authority to order. No other one will have the authority. Right? So now switch 1 will send the BPDU, switch 2 will not send the BPDUs. Yes, MacArthur, we are electing the root bridge on the basis of priority. And if on the basis of priority we are not able to elect one, then we will look into the MAC address. This is the default behavior. If you want to take the election based on the priority, you can manipulate that. But right now we are trying to understand the basic concept. Once we are done with that, we will be able to manipulate as well. Clear? Is it clear? Okay. Now, once switch 1 is elected as the root bridge, switch 2 will not be the root bridge and switch 1 will send the BPDUs now. Okay, it will send the BPDU from port number 2 and port number 3 as well. If you are producing something, if you are the manufacturer, if you are the developer, then it will cost you 0. After traveling some distance, it enters to the switch 2 and let's assume it cost the switch 2 as X. X is any number. Likewise, here the cost will be X. Now on every segment, we have 2 segments here. On every segment, one port will get elected as the designated port. Here we have the cost is equals to 0. Here we have cost is equals to X. So which one have the least cost right now? Where we have the least cost? On both ports on switch 1. Right? So both the ports of switch 1 will get elected as the designated ports. So this is the designated port. This is also the designated port. So we are done with second election as well. We have completed 2 statements. And last statement was there will be only one root port on every non-root bridge. So here when we received the traffic, when we received the BPDU, it was costing us X. It was costing X over here. So here we have the same value. So we are not able to elect any of the ports as the root port. So now we will look into the sender port ID. Now, Out of this port number 2 and port number 3 on switch 2, which port is nearest to the switch 1? Please speak up. Which port is nearest to the switch 1?
Port 2.
Port 2 is the nearest one. The reason being, it is a smaller port number. It will come first in the numbering system. So the port that is connected with the port number 2 of switch 1 will get elected as the RP or the root port. Now we have elected the root bridge, the designated port and the root port. Now all the remaining ports will get blocked automatically. So we are not blocking this manually. It will get blocked automatically due to the spanning tree elections. Right? Now the traffic from this PC1 to this PC2 will be traveling through this one link. Now at any point, this interface goes down. This port number 3 will get unblocked automatically. And once it is unblocked, the traffic will be forwarded through this to the PC2 automatically. We need not to undo shutdown. We need not to enable the interface manually by ourselves. It will be done automatically with the help of spanning tree. We are not going to do anything. Now, very interestingly, we are not going to elect anything. Spanning tree will elect root bridge, designated port, root port, everything automatically. More interestingly, we need not to enable the spanning tree. It is enabled by default. Everything is running for you on Huawei switches by default. What all you need to do is to connect the interfaces only, and that's it. Let me show you here. Here we are going to have the STP basic lab. And for that, I will connect two switches together. This is switch 1, this is switch 2. So let us see what happens.
I have a question, please.
Yes.
If you want to use load balancing between the switches, so STP will block that?
Yes, STP will support that, and we will be able to load balance the traffic as per our own choice, as per our own requirement. By default,
Need the additional configuration?
yes, it will require additional configuration and management. So we will manage, we will configure, we will manipulate the things. By default, STP does not support load balancing. So I have connected two ports between the switches, and here I am going to power up them. Yes, Umar, what does that mean? I'm not able to understand your question. Can you repeat the question and rephrase it a bit clearly? Okay, I have enabled the switches with the connections. Let me bring up the console. Here, this is switch 1. This is switch 2. Undo terminal monitor, undo terminal logging. So I am trying to disable the log messages because they're very noisy, they're very irritating message sometimes. Okay, for the spanning tree, your interface should be a trunk interface. That is the only requirement. Okay, type here display STP brief. Here you can see port number 1 is a root port and it is a forwarding port. Just hold for 1 minute. Someone is at the door. Just hold on for 1 minute, please. All right, here you can see on switch 1, gigabit 001 is the root port and gigabit 002 is the alternate port. And this is discarding. Switch 2 have display STP brief. Both ports are designated ports. Now bring this screen in front of you. Here you can see in our example, we can rename that this is the switch 2 and this is the switch 1. Both ports on switch 2 are the designated ports. So this is the root bridge. And one port is the root port on the switch 1 and other one is blocking or discarding. So everything is being calculated. Everything is being elected automatically. We are not doing anything. Right? Okay, for furthermore, you can type display STP. It will give you a lots of things here, keeping in mind this is the root bridge. So what is the priority number here? 32768. And this is the MAC address 4C1F. Display STP on switch 1. Here you can see this is the MAC address of switch 1 with the priority, switch 2, and this is the priority and MAC of switch 2. So compare it. Switch 2 have 32768, switch 1 have 32768, so no one is winning switch. 4C1F, it is same. It is double C, double 2, and switch 1 is double C 30. So which one should be the winner one? Whoever will have this MAC address. So this is the MAC address of switch 2. So switch 1 is the root bridge. Got it? Is it clear, guys? Okay. We can do one thing. This is the credentials of switch 1. Copy this to the notepad. Switch 1. Okay. We can remove the additional things. And after that, this is the switch. Go to the switch 2 and copy the second line, this one. Type it here. Now compare this 32768 and 32768. No one is a winner because the values are same. 4C1F, 4C1F. No one is a winner. Double C30, double C22. Which one out of these two have the least number? Which one have the least number? Switch 2 have the least number. So switch 2 will get elected as the root bridge. If you remember, then both ports which are connected with the root bridge, they are the designated ports. One port on the non-root bridge, that is switch 1 now. The first port was the RP or the root port, and the second port was blocking one. Agreed? Agreed or not? Okay. Same thing is happening here. I can show you again. Let us go to the switch 2 again. Display spanning tree brief. Both ports are in the forwarding state and they are designated. Role is designated. Switch 1, port number 1 is the root port, which is forwarding, and other port is alternate. This is the discarding port. Right? Port number 2 is alternate. Now, let us disconnect port number 1. So I'm going to remove the port number 1. Due to some reason, it got disconnected. Here, just hold on for a few seconds and type display STP again. Port number 2 becomes forwarding automatically. Moments earlier, it was discarding. I have not configured anything. You can see here. After removing the first port, the second port is in place automatically. Now, the port number 1 is recovered and we have connected port number 1 again. We have fixed the problem. Port number 1 is in place again. So you can go to the CLI and you can type display STP. The port number 2 is discarding now. Port number 1 is the root port. So do you need to manage anything by yourself? No, we are not managing anything. Everything is managed by the STP automatically. We are not doing any election. We are not doing anything. We have simply enabled the STP on the switch. And by the way, it was pre-enabled for us. We have not configured that. It was pre-configured for us. Right? Yes, guys, is it clear now?
Yes.
Okay, now someone asked me to configure switch 1 as the root bridge. We wanna manipulate, we wanna customize the spanning tree election. Yes, MacArthur, we can connect any port, no problem at all. All the ports have the same properties, so you can connect any port. So someone asked me to configure the switch 1 as the root bridge. So it is pretty much simple.
Switch priority, right?
Yes, exactly. Because we will not be able to modify the MAC address here. It is not possible. It is a fixed MAC address, so we cannot change that. However, we can manipulate the priority. If by some means I configure the less priority, for example, 4096. Now it is 4000, it is 32,000. If I configure 4000, then switch 1 will become the winner one. So let me configure here. Spanning tree or STP VLAN STP priority. STP priority question mark. It says how much priority you want to configure. I'm configuring 4096. STP priority 4096. Now type STP brief. Okay, just hold for a few seconds. Both ports are designated now, and it is changing the state from discarding to forwarding. Here you can see it is learning the network. It will take few seconds. Technically speaking, it will take 30 seconds. Okay, type again. Now moments earlier it was alternate and root port. Now because this is the root bridge, why this is the root bridge? Display STP, because we have configured the priority 4096. Now copy this here. Now which one should be the winner one? We will be able to elect switch 1 as the root bridge based on the first parameter, that is the priority. Okay. Now you can open up your lab guide here just to brief you in the intermediate, in the entry most likely. Yes, we had the spanning tree and rapid spanning tree. So we are done with 3.1, page number 25. We are done with configuring spanning tree. So you can open up the lab here. There are two switches which we are doing right now. You can see here. Enable disable spanning tree mode, bridge priority, control election, right? Change the port cost and edge port. So we are done with many things here up till here. Last point we have not discussed until now, so we will discuss that shortly. However, we are done with this point. So it says there are certain problems with the spanning tree. There are few problems with the spanning tree. Now, let us address the problems of the spanning tree. The first thing that is problematic with the spanning tree is the timers. The timers of the spanning tree are a big problem. In spanning tree, we have the timers and port states, or we can say the states and their timers. In spanning tree, the port may be disabled and it requires 0 second. After disabling, you will, it was disabled by default and you have connected the cable, it will enter to the listening state and it will remain in this state for 15 seconds. After that, it will enter to the learning state and it will remain in this state for 15 seconds. After that, it will enter into forwarding state and it can take 20 seconds to enter the forwarding state. It may be the discarding. So it requires 0 second. So in total, how much time you require to get a port into the forwarding state? 50 seconds. So be honest and let me know, is it adequate time? Is it an affordable time for you in a real network?
Very big time.
It is a very, very big timer. So that is the biggest limitation of the spanning tree, right? So due to this timer problem, we will introduce you to a new variant of the spanning tree that is known as the rapid spanning tree. Yani this is the faster spanning tree. In this spanning tree, we have the states, we have the timers, but this time we will have discarding, disabled, learning, and forwarding. Zero second, 0 second, 0 second, 0 second, and in total 0 second. Yani, the moment you will connect the cable, your port will enter to the forwarding state immediately.
There is no, in rapid, there is no listening?
There is no listening state.
Okay.
Okay. Now, what all you need to do in this topology, let me restart the devices first so that we may have a fair election. First of all, you need to configure the trunk links because it is very important to configure the trunk links so that you can have a fair election. I have only disabled the messages by undo terminal monitor, undo terminal logging, system view, and switch name. Okay, after that, go to switch 1. It was gigabit 1, port, link type, trunk, port trunk, allow pass VLAN all, interface gigabit 002, it is a trunk and allow all the VLANs. Interface 001, port link type, trunk, port trunk, allow pass, and all. Interface gigabit 002, and we have configured both link as the trunk links. First of all, we need to enable the rapid spanning tree. So we will configure STP mode RSTP, yani rapid spanning tree. Enter the same command on the other side, STP mode RSTP. So we are done with one thing, sorry, that we have enabled a rapid spanning tree on both switches. Secondly, just let me check first. So I have enabled the spanning tree on both interfaces of the both switches. Although it is enabled by default, but just to make sure, I am enabling the spanning tree on both interfaces. After that, on switch 2, type display STP. It will show you the mode of your spanning tree is rapid spanning tree. And secondly, display STP brief. Both of your interfaces are designated and forwarding interfaces. After that, disconnect port number 1. Before disconnecting, please confirm you guys are with me up till this point.
Affirm.
Okay. On switch 1 and switch 2, I'm going to remove port number 1. Immediately, the role will be assigned to the other interfaces. So here you can see it is route and forwarding on switch 1. I'm going to connect the interface again. Port number 1 is connected with port number 1. Go to the switch 1, display STP brief, and the moment you will type and enter this command, your port will enter to the discarding state. Other one will become route and forwarding. If you remember, then in the previous spanning tree, I told you that you have to wait for 30 to 50 seconds. But this time, this is immediate. The moment you will connect the cable, the port will enter to the forwarding state. Right? Is it clear?
Yes.
Okay. One problem still exists into this rapid spanning tree, and that is here. If we connect end user over here, now be active, listen carefully. These end user interfaces are not the trunk interfaces. STP or RSTP works only on the trunk interfaces. These two are the access interfaces. So STP or RSTP will not work on the access interfaces. So I can show you here. Let me remove the connection and connect it again on port number 5. Go to switch 1, type display STP. The port is discarding, port number 5 only. Discarding, still discarding. Now it is learning. You can feel the difference. You are getting the story? Yes, guys, you are there.
Yes.
Oh, out of 53, only one person is active. Please support me because it takes too much energy. It takes too much effort. Yeah, it is. Yeah, because I will get down if you guys. Okay. Now. Okay, just drop me the messages. Don't open up the mic. You can support me with the messages. So it will encourage me so that I can speak up with more energy. Otherwise, I will get down like no one is interested. So read out the slides and complete it and like that. So it is very important to stay connected, to stay up and up so that we can cover it with more energy and more efficient way. Yes, thank you. Okay, right now, there is a problem on these interfaces. First of all, disable the spanning tree on these interfaces. If the interface that is connected with the end user is listed in the spanning tree, then this is a problem. So first of all, go to interface gigabit 5 and type port, link type, access, display STP, brief, still it falls into the spanning tree. Now this is the case only with the Huawei switches. This is not the case with the Cisco switches, with the Juniper, with the Foundry, with the Nortel or any other. Here, this is a good thing actually. You have the control, you can enable and disable the spanning tree as per your choice. So you can go to the interface gigabit 5 and you will type undo STP enable. Yani, you are disabling the spanning tree on this interface. Now display STP brief. It is not part of spanning tree now. One last thing. Interface gigabit 005, type STP edge port enable. Now edge port means this port will bypass, this port will skip the listening and learning states. It will not enter into the listening and learning state. Now just to show you, let me enable STP enable just to show you. Display STP brief. Here port number 5 is listed, and the moment I have enabled the spanning tree, it enters to the forwarding state. This time it is not entering into the listening, into the learning, and then instead it is directly entered to the forwarding state. Right? Just to make sure, let me disconnect this interface and reconnect it. Port number 5 with the PC and go to the switch. Here you can see the difference. On the first outcome, it enters to the forwarding state. Got it? Is it clear for you guys?
So we need to disable the STP after that.
Yes.
The DH port.
Yes. Yes.
So it will be faster in the response.
Yes, in case of access ports, it is mandatory to enable the edge port. That is equal to port fast, if you are familiar with that. In other vendors, it is port fast. That
Yeah.
means it will skip, it will bypass listening and learning state, and it will enter to the forwarding state immediately,
Okay.
right? So we are done with the module 3 of this lab guide as well. So you can open up this lab guide and you can go through uh, the lab exercise, which I have tried right now. I have showed you. So until here, we have completed all the modules from module 1, 2, 3, and 4. Module 5 is part of discussion by tomorrow, not today, right? So I believe it is clear for everyone. We can move to the other topic now. And that is going to be the very important thing, link aggregation. And before switching to this topic, let us have a 10-minute break for the prayer. It is 12:26 on my side, so we can take a quick prayer break, right? And we will resume after that. We will resume at 12:40 after 13 minutes. Okay?
Okay. Thank you.
Yes, thank you. Thank you. Okay, ji, welcome back, guys. Let us resume. Let us move on further. Okay, is there any question regarding this spanning tree or the rapid spanning tree? Okay, if there is no question, then let us move on. It looks like there are only few candidates here. We had 56 and right now there are 45 and no one is responding. So let me move on. One person. Okay. Razeen is here. Muhammad Ahmed is here. Ahmed Al-Wani. Muhammad Badrudduja. Amjad. Adil. Okay, thank you, brothers. Thank you very much for being with me. It gave me like immense pleasure. Thank you. Okay, the next is link aggregation. Yes, Adam, thank you. Mohammed Khalil, thank you for being with me. Next is the link aggregation. Okay, it says spanning tree or even the rapid spanning tree or even any variant of the spanning tree still have the problems. Like, let me show you the problem. Here was the switch 1. Here was the switch 2. They are connected with each other like this. And we are using 10 gigabit interface here, 10 gigabit interface here. Both of these interfaces. Like this is the 10 gigabit, this is the 10 gigabit. Again, this is the 10 giga and this is the 10 giga. Due to this spanning tree, we are blocking, or spanning tree is blocking one interface all the time until or unless your first interface goes down. Yani, out of these two interfaces, you will be able to use only one interface at the same time. If you run the spanning tree, or even if you run the rapid spanning tree, you have to waste one interface all the time. Only one interface will remain active. It looks okay for you? Because it does not look okay, it does not suit me, because this 10 gigabit interface, this one port, will cost me more than the cost of a switch. I do not afford the wastage of this 10 gigabit interface, not at all. Right? So spanning tree is helping me out in terms of automation, but it is costing me too much. Right? So I don't like STP at all. I'm not a fan of spanning tree. Right? So what could be the solution? So someone suggested me to use both interfaces. He asked me to configure both interfaces logically as a bundle, like bundle them together, like this. When you will bundle them together, the switch 1 and switch 2 will feel like there is only one interface between them. Like there are two interfaces, we have bundled them together, and switch 1 will feel that I'm connected with the switch 2 with one thicker interface, like this. One wider interface. So this was 10 giga and 10 giga. So right now we are connected with one interface of the 20 giga. So both pictures are one and the same. And interestingly, here we were able to use only 10 giga. We were wasting one interface all the time. But this time we are able to use both interfaces. Nothing is going to be wasted. Everything will be working very fine. Right? Now, to bundle these ports, we use the concept of link aggregation. Right? Now, let me show you how to do that. You guys are with me? Is it clear? You guys are understanding the concept? For your convenience, I can show you here. It says, yes, Umar, I'm repeating. It says link aggregation. Link aggregation provides for increased bandwidth, enhanced reliability, and support of load balancing. It says if you will be using the link aggregation, you will have higher bandwidth. It will be a more reliable network. It will be providing you the load balancing. Like if we configure the spanning tree, we need to block two interfaces. Only one interface can remain active. But this time, using ether trunk, using link aggregation, all the links will be the active links on both sides. Nothing is going to be wasted. So in spanning tree, we had only 1 giga because these interfaces were disabled. But this time we have 3 giga. So it is providing you higher bandwidth. Now, if one of the interface in this ether trunk goes down, still my network will be in the running position, in up and up position. Nothing is going to be wasted. Nothing is going to disturb my network. If all the interfaces are active, then the traffic will be load balanced between them. One frame here, other here, third here, fourth here, fifth here, sixth here. So they will share the traffic between them. It says this is a typical application here in your enterprise network. You will see in any network, like I can challenge you, you can go to any network in your country, any network. You can bring the configurations to me. If it is Cisco, if it is Huawei, Juniper, Foundry, Nortel, Ericsson, Checkpoint, Nokia, Sims, anything, any vendor, there will be link aggregation. And if it is not there, you can ask me, you can ask me to revert the time. I will pay you back. It is, yeah, this is like the Ether channel. This is the same thing which is running in every network. So it says you can use the manual mode or LACP mode. You can bundle the ports together with these two mechanisms. So let me show you how to do that. Here is ENSP. We have two switches. First, I will show you the spanning tree. And I am going to connect 4 interfaces. Power up. Bring the console. So let me configure the trunk interfaces. So I have configured the trunk interfaces for both of the switches on all 4 interfaces. Okay, just hold for 1 minute, please. Okay, we have configured the trunk interfaces. Now, if you look into the display STP brief, out of 4 interfaces, how many are the active interfaces? How many interfaces are active right now? Only 1. Out of 4 interfaces, only 1 interface is active. Now I'm going to bundle them together, right? So interface ether trunk 1. I have created a logical interface. Go back. Interface gigabit 001 ether trunk 1. Okay, let us restart the devices first, because it requires 0 configurations for that. So you understand the spanning tree problem right now. So now I will configure the ether trunks configurations or the link aggregation. Okay, here on switch 1, I will configure interface ether trunk 1. Go back. Now interface gigabit 001 type the ether trunk 1. That's it. Interface gigabit 2 ether trunk 1. Interface gigabit 3 ether trunk 1. Interface gigabit 4 ether trunk 1. Go back and type display current. I'm showing you what I have configured. This is all what I have configured up till now. That's it. Nothing more than this. Go to the switch 2 and configure the same thing here. Display current, and you can see I have configured the same configurations on the other side. Yani, I have added all the 4 interfaces into one logical interface. Now, it will be a very interesting situation now. Display STP brief. How many interfaces are connected between switch 2 and switch 1? Physically 4 interfaces and logically only 1 interface. If you look into the topology here, how many interfaces are there? Physically, it is 4 interfaces, and logically, there is only 1 interface, right? And type display ether trunk, enter. It is saying all the four physical interfaces are active in this port channel. All the four interfaces are active in the port channel. And here you can see how many interfaces you can add in port channel. Maximum 8 interfaces, nothing more than that. Right? Now spanning tree is not able to block any interface. Now interestingly, due to some reason, port number 2 went down. Here you can see in the ether trunk, one is down and rest of everything is working fine. No problem. Only one interface went down, and yes, we have considered that as the down interface. The rest of the interfaces are working very fine. No problem. Right? So I believe this is clear to everyone. If you have questions, then please let me know. No questions? Okay. Okay, if there is no more question, then we can head to the lunch break. Yes, Sumar, we have to configure this ether trunking on both sides. Link aggregation needs to be configured on both sides, not one. Okay, then we can head to the lunch break. It is 1 p.m. So we can head to the lunch break. See you after that, and we will resume with the VLAN routing. Very important topic. No, 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 no. IP is not part of discussion yet. No IP yet. We are talking about layer 2 technologies. Yes, thank you. Thank you. Okay, we will resume after the lunch break. So it is 1 p.m. We will resume at 2 p.m. Thank you.
ممتاز. have voice modality.
Yeah.
Once they think like we got like
Yes.
Yes, welcome back, everyone. Let's resume. And we were supposed to start with the VLAN routing. So please confirm if you guys are there. So okay, so the next topic we are about to discuss is the VLAN routing. Or normally this is known as the intra-VLAN routing. So we started today morning with the VLAN concept, and into the VLANs we had few problems, and someone was asking about what if we wanted to communicate between different VLANs. So we started with the isolation of the ports, and we have used the concept of VLAN for that. Just hold on for 1 minute, please. Okay, we started in the morning with the concept of the VLANs. So right now we are going to discuss the VLAN routing. So here it says the disadvantages of the VLAN. If you remember, then we have isolated the ports from each other with the help of VLAN. In that case, the users of the same VLAN, like the users of the VLAN 100 are able to communicate with each other. The users of the VLAN 200 are able to communicate with each other. However, the users of different VLANs are not able to communicate with each other, right? So read out the line given here. Attempts to limit broadcast domain size through VLAN implementation isolate the users. So does it make some sense to you? So it says we have started with the VLAN that was aimed to isolate the users from each other, right? Now we are facing the problems that VLAN 100 users are not able to communicate with the users of the VLAN 200, right? So that is the disadvantage of the VLANs. In that case, we are unable to communicate between different VLANs. So it says we can use the VLAN routing concept so that we will be able to communicate between different VLANs. Interestingly, we will be able to avoid the broadcast between the VLANs. Likewise, we will be able to communicate between them as well. So it says VLAN frames are routed over a trunk link for port conversion. So here we are actually using a layer 3 device. Here you can see there is a router, and we know a router does not support broadcast, right? Broadcast is not supported into the router, or router is a device which does not that does not support the broadcast for the user traffic. So now the VLAN 2 traffic will reach the switch. This will be the trunk interface. It will carry the traffic of the VLAN 2 to the router. A router will convert the VLAN 2 traffic into the VLAN 3, and you will be able to reach to the host B, which is sitting in the VLAN 3. If you are using a router in this scenario, then this is normally known as inter VLAN routing, or in some vendor this is known as router on stick. Here is a stick, we have placed the router over there, so that is router on stick, right? In that case, we have to configure, we have to use the sub or virtual interfaces onto the router. So it says here, you can see router A was connected with the gigabit 001, but we are using gigabit 001.1. Likewise here, it is gigabit 001.2. This is a trunk interface, and these are the VLAN interfaces. So let me show you how it works and how to do that. So here is a router, here is a switch, and there are few users in VLAN 10, few users in VLAN 20 or VLAN 30 or any VLAN. So gigabit 0 is connected with the switch 1 on port number 1. Port number 2 and 3 is connected with these two computers. 4 and 5 are connected with the PC4 and power of the devices. Keeping in mind, this is one VLAN, this is another VLAN. Right? One is a blue VLAN and other is the white VLAN. No, Omar, I will explain that as well. But right now, let me do it. On the switch 1, we have VLAN batch, VLAN 10 and 20 is there. On port number gigabit 002, this is port link type access, port default VLAN 10, interface gigabit 003, it is access and part of VLAN 10, interface gigabit 004. It is also access interface, but this is part of VLAN 20. Interface gigabit 005. This is access interface and it is part of VLAN 20. So as per previous in the morning, if you remember, then we have configured the same things here. I have configured these 4 interfaces. So you can take a look into the configurations. If needed, then you can note the configurations down as well. Yes, Umar, I will not hurry up. Don't worry, all of you, don't worry. I will show you, I will confirm from you, and then I will move on. So right now I have configured these 4 interfaces only. Port number 2 and port number 3, they are sitting in VLAN 10. Port number 4 and 5, those are sitting in VLAN 20. I believe you guys are okay up till here. Yes, Umar, is it okay? Yeah, don't worry. Today I'm not in hurries. I'm very slow today. In our native, you can say, we call it, today I had few sip from the coriander, right? So don't worry. And now let me assign IP addresses. This is the user from VLAN 10, so I'm assigning 10.1.1.1. Here it is 10.1.1.2 and apply. This PC3 belongs to the VLAN 20, so this is 20.1.1.1 and apply. This is 20.1.1.2 and apply. So right now these 2 users will be able to communicate with each other. The other 2 users will be able to communicate with them. So PC1 will go to 10.1.1.2 without any problem because this is the same VLAN member. Ping 20.1.1.1, host is unreachable. Got it? Okay, now we wish to have communication between these 2 different VLAN users so that we will avoid the broadcast as well as we will be able to communicate between them. So for that purpose, I will configure this switch interface gigabit 001 as port, link type, trunk, port trunk, allow pass VLAN all. So this is one additional thing on the switch 1 side. This is the link which is connected with the router. Okay, now it is turn to go to the router. So on the router side, this is R1. On interface gigabit 000, you will type undo shutdown and undo IP address. We cannot record the session. However, if needed, then I can share the notepad configurations. I can show you all the configurations in the notepad and you can record, you can take the picture. Okay, after this, you will configure. Yes, I will share I will show you the notepad configurations and you will be able to take the picture. Let me complete this first. Then you will configure interface gigabit 000.10. Now, this is not a physical interface. This is a logical and child interface. Enter. You will type .1q termination VID VLAN 10 and your IP address here is 10.1.1.254. Likewise, on other interface, you will configure the VLAN 20, that is the VID or the VLAN ID. Then you will configure your IP address 20.1.1.254, or you can configure any number. Yes, Umar, you can use any number of your choice. This number has nothing to do with the VLAN. This is any number of your choice. You can use your lucky number, you can use my lucky number, you can use any number of your choice, no problem at all. However, this number is important. The .1q termination number, that is important. That is the VLAN number. This number will associate you with the VLAN. Okay, now, one important command that is required in case of Huawei, not the other vendors, that is R broadcast enable on both interfaces. Now let me show you all the configurations into the notepad and then you can take the picture. Let me show you here. On switch 1, it was VLAN batch 10 and 20. Then I have configured these interfaces on the switch 1. After this, I have R1 or the router 1 and I have configured this one interface. That's it. On this interface, I suggested you to configure 2 additional lines. Just as a best practice. If you will not configure, it will not affect you. However, this is recommended. This is the best practice to configure. So these are the configurations which I have added over there. You can take the picture. Just hold, let me bring you the topology as well. Just for your convenience, let me bring up the topology as well. Okay, now you can take the picture of whole screen, which will help you. If required, then I can show you the interface and the device numbers here, the port numbers. Okay, now you can take the picture. Okay, you noted? Yes, that IP address will work as a gateway address. That will be the gateway address. So I believe you have took the picture. So let me add the gateway IP address, that is 10.11254. 10.11254. 20.11254. 20.11254. Apply, and that's. Now, if you remember, then moments earlier, you were not able to ping 20.1.1.2. Let me try again. This time, you are getting the replies from which IP address? Reply is coming from 20.1.1.2. That is the IP address of the user sitting in the other VLAN. Right? Okay, that is the VLAN routing with a router. Now, if your switch is a layer 3 switch, then you need not to have a router over there. You can stop the router. You can remove the router, right? And you can use this switch as a router. You can configure the IP address on the switch. Right now, I have removed the router, so you will again not be able to communicate with the PC3 because the router is not there to support you. So you can go to the switch and you can configure interface VLAN 10, and you can assign your IP address here, that was 10.1.1.254, and likewise on interface VLAN 20, you can assign your IP address here, that was 10.1.1.20.1.1, sorry, 54. That's it. Only these two additional commands are required. After this, you will again be able to communicate from the PC1 to the PC2. Here you can see now your switch is working like a router as well as a switch, right? So both of the functionalities are being done with the help of a switch. So you are able to have the inter VLAN routing on a switch, on a multi-layer switch, you can say. So let me go through the slides here. It says VLAN routing configurations looks like this. You have VLAN 2 for one user, VLAN 3 for the other user. There is a router which is configured as the trunk interface. After that, you will configure the .1q termination, IP and ARP broadcast on both interfaces of the router, and that's it. After this, you will be able to communicate between them. So here it says if your switch supports you with the multiple IP addresses, then you can use the router, a switch as a router, and you can configure the VLAN 2 and 3 interfaces over here. So to configure that, first it is showing you to configure the access interfaces with the VLANs, and here is the configurations for the layer 3 switch. So you will create VLAN 2 and VLAN 3 IP addresses here, and that's it. That is the only requirement. After that, you will be able to have the communication between different VLANs. So is it clear for everyone? Yes, Umar, VLAN 1 is default VLAN in case of Huawei. But that is not required at all here. That is not part of discussion here. However, let me repeat it. Display VLAN. VLAN 1 is here by default. But that has nothing to do with the inter-VLAN routing. Is there any other question you are about to ask? Or I am unable to understand your question. Can you rephrase? Yes, all the ports are by default into the VLAN 1. We have discussed that in the morning. Okay, guys, if this is clear to everyone, then we can move on. Yes, thank you. Thank you, Umar. So we have the next topic after this VLAN routing, that is the DHCP, FTP, and Telnet. So we will try to cover them today. But before, open up this VLAN routing slideshow, and now you will have the lab exercise. Create this lab topology and have the lab exercise. I have shown you that how to configure that. Furthermore, let me look into the lab guide. If required, then we can move on with the lab exercise from the lab guide. Let me check. Yes, configuring layer 3 switching, lab 1-4. So here, this is the topology, and here it is asking you to configure VLAN 3, VLAN 4, and VLAN 5, VLAN 5, 6, and 7, and configure the inter-VLAN routing between them. So you can use this lab topology, or you can use the slideshow lab topology, and you can move on. You can complete that here, or you can use the slideshow for that. Right? So we have 30 minutes for this lab exercise. Right now it is 2:30. So we have 30 minutes to complete the VLAN routing topic. For your reference, it is lab 1-4, configuring layer 3 switching from intermediate lab guide, or you can use the PPT slideshow that is named as VLAN routing. So please move on with that. Once you are done with that, please post your message here. We will resume after 30 minutes. Thank you.
في إيجار أصلا. إيه 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 اجتماع. إيه.
السلام عليكم سير.
أولا
Hello, can you hear me?
Okay, welcome back everyone. So guys, have you completed the lab exercise?
Yes, Assalamu alaikum, sir.
Walaikum assalam.
Yeah, sir. I contacted you yesterday, and I'm still
Yes.
facing that issue regarding the ENSP.
Okay.
Whenever I start a node, it keeps looping. The device is starting, and it keeps on going without even starting the device.
Okay. Show me the screen. Let me look into.
Okay. Give me a second.
Okay, your AR is inaccessible here in the WLAN. Show me the VirtualBox variant. Go to the VirtualBox help at the top. Okay, 5 to 28. Okay, fine. Go to the start menu and type the firewall. Okay, here is private public call. Okay. Okay, go to the ENSP. Remove this router. Go to the menu at the right top corner. Option Tools, Register Devices, AR Base, checkbox, Register. Fail to register. Yes. Okay, close that. Show me the VirtualBox. Go to the file. Preferences. Sorry, Virtual Media Manager. Expand the AR base. Okay, click the first file after AR. Yes, remove. remove. The third file, yes. Yes, remove. Okay, select it and release. Yes. Okay. Click OK. Close. Okay, select the last AR clone. AR clone, yes. Remove this. Go to the ENSP now and register again. Failed to register. Exit. Go to the network settings. Change adapter options. After advanced network settings, okay, open up. Change adapter settings. Double click. IPv4, double click. Okay. Obtain an IP address automatically. Okay, cancel. Don't select. Cancel and cancel. You have assigned this IP by yourself or it was pre-configured?
Maybe he needs to restart the ENSP.
Just 1 second. Okay, go to the VirtualBox. And here, yes, here global tools at the right top. Here will be the host network manager. Okay, properties. DHCP server. Just 1 second. Okay, it is fine. Then okay, close this one. Yes, machine tools back. Try to register it again in the ENSP, and if it is not registering, then yes, check it. Yeah. Okay. Yes, close it. Okay, we will discuss that later on because right now this is the thing which I know, so we can look into later on. Yes, thank you. Okay, I had another question that was from Jahazib. I have multiple switch layer 3 Huawei and one core switch and assign IP address. Meanwhile, guys, is there any other question? Jahazib, what is the model of your core switch?
It is S7706.
So what is your edge switch model? Okay, I will let you know. Let us complete the next things. I will let you know. Okay guys, let us move on. We have completed VLAN routing. It seems there is no more question in that. Okay, until here we have covered all these topics, I believe, until here. After that, link aggregation, VLAN principles, and VLAN routing. So all these topics are clear to you guys? Okay, excellent. So the next topic we are going to discuss is the DHCP. DHCP is the Dynamic Host Configuration Protocol. We understand that we can assign IP addresses to the devices in two ways. One is the manual assignment, which we have been using until now, and other is the dynamic that we are going to discuss right now. So it says for the DHCP, it is a core application of the enterprise network comprising of large number of users require a central management system for IP address allocation. This is very obvious thing that if your network have hundreds of users, then practically it is not possible to assign IP addresses to all those users manually. So we want to have some central management or central IP management system so that we can assign IP addresses to the end users automatically. So for every user, whenever you power up a system, when you power up a user, when you power up a computer, it acts like a newborn baby. Like it will start crying, it will start sending the messages on the network asking that to whom I belong, what is my identity, who I am, right? So it will start sending the messages. Those messages are known as DHCP discover messages. Yani it will start asking the network devices that who is the DHCP server, who is the device which can assign IP addresses to me so that I can connect to the network. So that message is known as the DHCP discover message. That is here. The DHCP server will respond back with the DHCP offer, telling him that don't worry, don't cry, be patient. I am the DHCP server. I can assign you IP address, but it is not assigning yet. It is just telling him that I am the DHCP server. Now the client will send the DHCP request message to the DHCP server. That is known as the DHCP request, and the server will respond back with the DHCP acknowledge. That is the DHCP acknowledgement. This is a four-way handshake between the client and the server to assign and obtain IP address, right? We normally call this process as the DORA process, discover, offer, request, and acknowledge process. right? Okay, here we have two options. We can configure the DHCP server to assign IP addresses from the global pool, or we can create a interface pool to assign IP addresses. The global pool means you will configure a global pool, you will configure a pool of IP addresses into the global configuration mode or the system view. And the interface pool means you will be able to configure the pool of IP addresses into the interface mode. There is no need to configure the pool into the global mode. So let me show you how to configure a global pool and how to assign IP addresses from the interface pool. So we have one router that is connected with a switch, and there are number of users here who are supposed to obtain IP addresses from the router or the DHCP server. You can configure the switch as well. Any layer 3 device could be configured as the DHCP server. Like in your home network, you have the service provider router that works as the DHCP server. Whenever you configure your mobile phone as the hotspot, it works like a DHCP server, and it assigns a new range of IP addresses to the mobile phones which are connecting with your hotspot. So it could be any device. You can configure your mobile phone, router, switch, computer, server, anything. Okay. This is R1, and on interface gigabit 000, we have IP 200.100.50.1 to 555.0.0.0. This is the IP address of the DHCP server. Now, IP pool, for example, DHCP, you can name it anything. We are supposed to assign IP addresses to the users from this pool. Right? And the gateway list is after that, go to the interface gigabit 000 DHCP, select from the global. It says DHCP enable. So let me create the DHCP configurations for you on the notepad so that you can have the topology and configurations available to you on one page. Although it is available into the PowerPoint slideshow, but again I am showing you how to configure. So here, these are the configurations which I have configured here. Yes, Adil, I will answer that. So please take the picture of the configurations and the topology, then I will explain rest of the things. Okay, I believe you have noted. Now go to the PC1 and type IP config, and it is showing you 200.100.50.253, 255.255.255.0, 200.100.50.1. all these configurations are assigned to this device automatically because I have not configured anything. I am selecting the DHCP, right? So it is able to obtain IP address from the DHCP server. Router 2, this is also obtaining, computer 2, this is also obtaining the configurations from the DHCP server. You can see here. Likewise, the PC3 command prompt ipconfig, it is also obtaining IP address from the DHCP server, and PC4, this is also able to obtain IP address from the DHCP server. So this is all what you need to do for the DHCP.
Can we see the notepad, please? 1 minute.
Yes, why not? Here.
What's the DHCP select global used for?
That means, yes, that means the IP addresses will be assigned from the global pool which you have created above.
Okay, so when I don't put any number after IP pool, it will be the global, right?
No, come again.
If we don't put any number after IP pool DHCP in the beginning, so it's the yes.
This is the name of the pool. You can name it anything. For example, you can name it anything. This is
how
the
can
name.
I create another pool? What I will put
With the same command, like you can create IP pool, for example, 00.
Okay,
and
okay.
Network.
Yeah, but how the DHCP, the switch will know which is the global pool?
How the DHCP?
How the switch will know which one is the global pool? Is it the PPP or is it the OOO?
Oh, you want to differentiate between them. Yes, we can differentiate between them here. Let me check. DHCP select global. DHCP select. Now you can go to the interface gigabit 000. DHCP select global, right? So it will be able to differentiate between them with the IP or with the network. You need not to mention the name of the pool.
Okay. So based on the interface IP.
Yes, interface IP and network ID, it will be able to differentiate between them. Okay, here there is another question from the other member. Okay, IP conflict normally occurs when you have multiple users, or you okay, just as a fun, you may not have a like manageable or good device, or you may have some other reason. It says we notice IP conflicts here. IP conflicts normally occurs when the previous IP address is not released and your device have the lease expired, right? So that could be the possible reason. Yes, we always need to enable the DHCP server We always need to enable the DHCP service on the switch so that we can use that switch as the DHCP server. Otherwise, we will not be able. Yes, Umar. Display current. Here are the configurations which I am showing you there on the notepad, as well as here into the router. Okay, Adil, I did a recent install and connected the service provider modem to the switch, but it would not pick the IP addresses. I had to add a small router in between. That could not be the case. There will be some other definitely technology or parameter involved. Otherwise, this could not be the case. It should not be like that, right? Because I don't want to create a fuzz or confusion. So I'm not clear what could be the possible scenario, right? No, if you are configuring your device as the DHCP server, then you have to enable the DHCP over there. Right now, I'm not doing anything on this switch. I am configuring only this router 1 and these computers. That's it. This switch is providing me the connectivity only. I'm not doing anything onto this switch 1. Yes, Umar, I am showing you here. This is to enable the DHCP services on the router. This is to create the global pool. Like this is a bucket with the router. In that bucket, I have lots of IP addresses placed, and those IP addresses are from this series of addresses. And the net mask is 255.255.255.0. This is the gateway IP, which I am supposed to assign to the client users. And to the users, I'm asking the router interface to assign IP addresses from the global pool. That's it. Okay, guys, now let me remove DHCP pools. No worries, brother. Right now, you can see I have only two things. Let me clear the screen first. I have only two things. One is the DHCP enabled, and the second thing which I'm going to configure is DHCP select interface. That's it. Only two commands. Let me copy this for you again on the notepad because it looks like it is much easier as compared to typing over there. So it is much understandable. So this is what I have configured right now. So you can take the picture.
الله وش ثاني ما يهم الجودة يخلص أمورك بس بأكثر ممكن
All right, guys, if you have noted this, then let us verify. Right now, if we go to the PC1, let me click on the static, apply, go to the configurations. Here you can see there is no IP address here. If the screen is updated to you, then please let me know. Okay, so I will select the option DHCP into the basic configurations, apply, go back to the command prompt and click again. It will be able to obtain IP address after a few seconds. Until now, it is not able to obtain IP address. Okay, let me check if I have removed configurations or not. DHCP enable, DHCP select from the interface. Yes, there is no problem into the configurations. Let me do that. Yes, right now we are not creating the pool, right? We are using the interface IP range. This is not available in other vendors. This is the case only with the Huawei devices. In case of Huawei, we can create the DHCP server on the interface level. Yes, here you can see first it was able to obtain the gateway. Now it is able to obtain the IP address successfully. Keeping in mind, we have not created any global pool. Instead, we are obtaining the IP addresses from the interface pool, right? So is it clear, guys? Yes, is it clear? Okay, if it is clear, then let us move on. We have two topics. You mean if we need 10 interfaces to get IP, then only 10 will get from. Ahmed, your question is not understandable. Can you repeat it? Yes, Suleiman?
Assalamu alaikum. Sir, I am saying, suppose there is a switch and we need 10 interfaces on the switch to get IP address from there from DHCP. So only the 10 interfaces are going to contribute in that thing, or the entire
No,
switch?
it is not about, the interfaces. Actually, if your 10 interfaces are connected with different switches, then you can consider, for example, these are 5 right now. These are 5 switches connected to the router, and 5 interfaces can work like 5 DHCP pools, right? So your router will act like a DHCP server, having 5 pool, one for this, one, and one. Yes, thank you. Suleiman, there is no specific timer for that. Whenever you will power up the device, it will start sending the discover messages. Yes, Khalil, if you want to configure the DHCP exclusion, you can go to the interface and you can type DHCP excluded, I'm sorry, not DHCP, excluded address was IPDHCP command. I remember. Walaikum assalam. Let me check. It was DHCP. Yes, DHCP server excluded IP address. And for example, you can exclude your IP address, or you want to have 10 to 200.100.50.20. So this is the command to exclude the IP address from the DHCP server. Okay. Okay, guys, let us have a tea break quickly, and then we will complete the next two topics, that is the telnet and FTP. So we can take a quick break. It is 3:40, so we can take the break till 4 p.m. Last question between global and one more time quick way. Okay, for the global pool, you will type DHCP enable IP pool, for example, ABC. Mention your network which you want to use to distribute the IP addresses. Or you can use the smaller instead. This. And gateway list. This is the gateway. To the interface, type DHCP, select. This is one thing. This is the global pool configurations. If you want to use the interface pool, then type DHCP enable interface gigabit 000 DHCP, select interface. That's it. Is it clear now? We can discuss that. Yeah, we can discuss that after the break, but we can configure that as well. I have no issues. I will explain that. Okay, see you at 4:10 inshallah.